Hi all, I'm Ankur Gupta and welcome to Analytics School. In this tutorial, we will learn how to efficiently explore the Pandas DataFrame. When we have loaded our data into a Pandas DataFrame object, the first thing we should do is to inspect the data before the analysis. The main intention of inspecting our data are to get an idea of the size of the dataset, to get the data type of each variable in the dataset, to identify whether there are missing values in the dataset, and much more. All these things will give us an idea that where we are going to focus in our next step of data wrangling task. Pandas provide efficient ways for inspecting a Pandas data frame, and all these can be done using the appropriate methods and attributes of Pandas data frame object. Now let's import the necessary libraries and import the Tableau sample superstore dataset. So libraries we are going to import as pandas, and we are going to give an alias as pd as well as numpy, and we are going to give the alias as np, and we are going to use the parameter parse underscore dates, and we will pass a list of ship date and order date. By using parse underscore dates parameter, we can read a column as a date type data type. Once you load the dataset, you want to quickly explore it and get a sense of its content. Pandas has several methods for this. The first is the head and tail method. Head method returns the first 5 records of the dataset, whereas the tail method returns the bottom 5 records of the dataset. Let's see both those methods in action. What we will do, we are going to call the head method with a data frame. As I said, it will give you the first 5 records. And you can see here the first 5 records for this particular dataset, and you can verify by these index positions 0, 1, 2, 3, 4. And you can see the column names, order date, ship mode, customer ID, customer name, and there are total 20 columns are there in this particular dataset. You can see some of these columns are categorical, some of them are date time data type, and whereas some of them are numerical data type. Similarly, tail method gives you the bottom 5 records of a dataset, and you can verify them by the index position of the data frame. And here you can see there are 5 records from the bottom of the dataset, starting from 9989, and it goes till 9993. In this data frame object, there are total of 20 columns in the data frame. Some of the columns are categorical, while others are numerical or data time in nature. For example, sales and profit are continuous variable, while category, subcategory are categorical variables. Once you are aware of how the data looks like, you can plan your analytics strategies. Generally, after having a look and feel of the dataset, I would like to know that how many number of observations and number of columns are there in a data frame. And that is where the shape attribute of the data frame comes in handy. The shape attribute provides a tuple that holds number of rows followed by the number of the columns in a data frame. Since this is an attribute instead of a method, we write it without parentheses. We are going to call the attribute now, shape attribute. And you can see the output is 9994 records and 20 columns. We could have retrieve number of records by using len method also, which gives us 9994 records. Whereas if I want to retrieve how many columns are there, I could have used the columns attribute, and in this particular way we generate the same output what we have got from shape attribute. There is another way, means there are so many ways in Pandas, and there are so many attributes and method. You can you can receive you can retrieve the same information in n number of ways. We can use columns attribute with size attribute, and we will receive the same information about that how many number of columns are there. By the way, in Pandas DataFrame object, we can call n number of the attributes or methods, and this particular process is called chaining. Once we get all these information, I would like to check the data types of the variables. For this, we are going to learn one method and one attribute. Let's see those. The attribute is dtypes. What does it do is it is going to provide you for every variable how the data has been stored. For example, order ID has been saved as an object, order data as date time, data type, ship mode as an object, postal code as float, and sales as a float, quantity as an integer. Now, for some reason, let's say you want to create a data dictionary and you want to create a summary that how many variables are object data type, which means the string data type, how many of them are date time, and how many of them are integer data type or float data type. For that, we can do dtypes, and we are going to use value underscore counts. And it is going to provide you the information that how many object data types are there. 13. There are 13 variables with a string data type, 4 variables with float data types, 2 variables with date time data type, and 1 with integer data type. We can also use the info method of the data frame. This will return both the data types, number of non-values for each column. In addition to that, this will also return the amount of memory taken by the data frame. So let's see that. So you can see here it is providing us lot more information than what dtypes provide. So here it is telling you that what type of the data it is. It is a data frame, not a series. Range index is basically it's a default index. Data columns, there are total number of columns 20, and then it is providing you the information about d types, how many means not null values as such, but it's telling you that how many number of records are there, 9994 non-null records, but there is one postal code which is providing you the information that there are some missing values. And you might be wondering that how could postal code be a float? Means generally it should be a zip code and it should be an integer. There cannot be any decimals with that. So if there is any missing value for the numerical data type, then that particular data is generally saved as a float data type. And here you can see it is also providing you how many number of variables with the string data type, integer is with 1, float is with there are 4 variables with float data types and 2 variables with date time data type, as well as it is also providing you the information about the memory usage. The issue with this particular method is that you cannot save it. Let's say asd equal to df.info. See, it is not giving you any output. So that is an issue with the info data type, that you cannot save as information into any variable. In real world, data is generally not very clean and it will contain a lot of missing data. So we are going to learn now how we can identify variables with missing data and what are the methods for those. So let's say we want to calculate the total number of missing values in a data frame. For that, we are going to use isNull method and we are going to use sum method twice. It is going to give you the total number of records. Oh, my bad. This will give you the total number of the records in a data frame that has missing values. So total number of missing values in a data frame are 11. Now we want to identify which variables have missing values and how many missing values are there. So we are going to use isNull method again, and we will write sum. So it will give you the variables and if they have any missing values, number of missing values. So for example, order ID, order date, they do not have any missing values. In fact, except postal code, none of the variables have missing values, and postal code has 11 missing values. So we can detect missing values in the data set for every column by using isNull method. So how does this work? The isNull method returns true and false for each value indicating the value is null or not null. And the sum method gets the column wise sum of true and false. Note that at the back end, true is saved as 1 and false is saved as 0 in Python. So what does it mean? If I use just df.isNull, it will give you a value of true and false for each value indicating that the value is null or not null. So you can see here, and this is not going to solve our purpose that how many records are null for a particular variable or how many records are null for in a data frame. Let's say if you want to see those records where we have null values. So for example, we have postal code where we have null values. What we can do here, we will use the square bracket notation and we will come back to it. We will do more examples of how to treat missing values later on. And we will use values attribute with isNull method. And it will show you the records where the null values are there. So postal code has 7 null values and you are postal code has 11 null values and you are seeing those records only. Do not worry, we will come back to it in more detail. I'm just trying to show you how we can inspect the data frame where we have null values. So now these 11 records are there in front of you and you can analyze it, why they have the missing values. Is it an error while entering the data or some other reason? There are two more components of a data frame. One is columns and the other one is index. The column attribute contains column names and the index attribute contains the default row numbers or the custom row names. For that, we can use, to get the details about columns or index, we can use these attributes. One is df.columns. So df.columns is basically going to provide you the list of all column names. Similarly, df.index is going to provide you the index labels for a data frame. Here it is a default index, which is a range index, and the range index here is providing you information about the data frame starts from 0 and stops at 9994. Let's say you want to view some basic statistical details like mean, percentile, standard deviation, etc. In that particular case, describe method will be of lot of help for you. Let's see that. So we are calling a data frame df and then we will call a describe method. By default, it is going to provide you the stats details for the numerical columns. So sales, quantity, discount, profit, they are all numerical columns, numerical data types, and it is providing you the details for those. Postal code has been saved by default as float 64. So it is also giving you a detail for that, but ideally it should be saved as a categorical data type. So you can see here for sales, number of counts is 9994, mean value is 229.86, standard deviation is this, minimum value is 0.44, this is a 25th percentile, 75th percentile, and the max value is 22,638, which is an outlier. Similarly, if you want to get the detail, by the way, by default, describe method is going to give you the details for numerical columns only. Let's say you want to get the details for the object data type or string data type. In that particular case, you have to call this describe method only, but this time you have to pass include equal to as an object O data type. And you can see here you get the details for the categorical data type, and it is providing you the information that for example, let's say ship mode has 9,994 records, unique values are 4, top value is means the mode is a standard class, and frequency is 5,968. And you can see you can get the details for the other categorical columns too. Let's say if you want to get the details for both numerical and the string data type together, in that particular case, what you can do here, we have to pass a parameter include equal to all, and it will give you details for both numerical as well as object data type. Now we are going to discuss about the methods which are related to categorical variables, and they are unique and unique value underscore counts. Unique method is going to provide you the list of distinct values of arrays for a particular variable, whereas NUnique is going to provide you a series where index is going to be the column names and how many distinct number of values associated with that particular column name. And value underscore count is going to provide you for a specific variable and what is the frequency of values within that particular variable. So let's see, for ship mode is a variable, and we are going to see what are the unique values in ship mode variable. And you can see here the unique method is provided as an array with the distinct values for the variable ship mode. Second class is standard class, first class, and same day. Now we are going to see NUnique method. And as I had said, it is going to provide us the series where the column names are going to be the index, and the values here will be the distinct number of values associated for the particular variable. So for example, ship mode has 4 number of distinct values, and you can see here second class, standard class, first class, and same day, they are 4 in numbers. Similarly, region are also 4, country is 1, segment is 3. Now we are going to see the value underscore counts method. df, let's say, so we know that there are 4 values associated with ship mode, but we do not know the frequency. How is the distribution of these values are. So what we can do here is we can pass the variable df ship mode, and then we will call our method value underscore counts, and it is going to provide us a distribution of those values. And you can see here the value underscore counts has provided us the frequency for the values related to the variable ship mode. Standard class 5,968, second class is 1,945, same day has 543. Now let's say if you want to see these values as a percentage, we can pass a parameter called normalize, and if we will pass it, it will give us the value in the frequency distribution in the form of the percentages. And you can see here standard class contributes around 59% of total ship mode, second class provides 19.46%, first class 15.38%, and same day contributes only 5.43% of the total mode types for this particular data frame. Inspecting any data set is very, very important, as it helps you to understand your data as well as also provide you the guidance that what type of the wrangling methodologies you should use to clean up your data for further analysis. In the next session, we are going to discuss in detail that what are the Pandas data type, as it will be very helpful for you to use the correct data type for your variables. So till then guys, have a good day and bye bye.